Okay everyone, so let us start with the topic called linear momentum, and this topic linear momentum is going to be used in most of our physics after this. So we're basically going to focus on this linear momentum. Many people call it linear momenta, like this new topic called linear momentum. So what is this linear momentum? First, to understand anything, we need to understand what is it. What is linear momentum? Linear momentum is linear momentum of any particle is defined as product of its mass and velocity. So what do we get? Physics definition. Like we can say it is a simple value of any particle, like your mass and velocity. It's a product. So which type of quantity is linear momentum? Think for a second. Which type of quantity is it? So if we find it, solve it. Mass is a scalar. Quantity. What is velocity? A scalar, right? No, it is a vector quantity. Mass is a scalar quantity, velocity is a vector quantity. What do we get? I studied it in the chapter called Mathematical Tools. Scalar multiplied vector. What is it? It is vector quantity. What does that mean? That linear momentum is going to be, what is it going to be? A vector quantity. So we can also use the term, erase this term going to be, and what can we replace this term with? Is a. Can we just delete this term whole term? So this is going to be very close definition of linear momentum, types of quantity. So let me write in the formal way because many of you will be confused. Okay, so how do we do it? Linear momentum is a vector quantity. And if you want to learn about vector quantities and how do we solve these type of quantities, go and check out the lectures on mathematical physics. So this is the case. This is the definition and this is the type of quantity. Now, what do we have? Next one. As it is a vector quantity, it will definitely be represented like this in the top of the letter, which is used to represent linear momentum. So, how do we write it? Linear momentum is denoted as P vector. That means the letter P is used to represent linear momentum, and this sign vector is used to represent that it is a vector quantity. So we learned this. So how can we find the formula of linear momentum? Basically, from the definition itself, E vector is equal to m into v vector. So be a grown up and write this formula like this, not like a kid. We write it in class 9 definitely. This is correct and this is wrong. So we need to take a look at these very small factors, because these can cut the numbers. Okay, so this was the introduction of linear momentum. What next we have to learn is the principle of law of conservation of linear momentum. So this is a very long line, but we can remember it just like a formula, which is this is the case like m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2, and let me make the diagram here to understand this very well. This is the mass m1 going with the initial velocity u1, and this is the mass m2 going with the initial velocity u2. Now after whatever happens to them, like they collide, etc., etc., this is m1 going with final velocity v1, and this is m2 going with final velocity v2. So why is this principle called conservation of linear momentum? Is because the term m1 into v1 vector is just a linear momentum of that particle at that time interval, basically. So all of these terms are just linear momentum, but we can express it in the direct form of linear momentum. That's why we write it in simple form. So definitely this formula is going to be very useful to solve many questions. So our next and last topic of this chapter, linear momentum, is going to be linear momentum of discrete particle system. So many students were like, what is this discrete particle system basically? So let me understand it to you. So I need some space. You can copy this part down because I'm going to erase it. Okay, so I'm going to delete the part from this chalkboard. First of all, what is discrete particle system? discrete particle system is a group of particles. This is very crude definition. What is the next definition? Not in contact. What does that mean? That the particles should not be in contact, otherwise it is going to just form a body. So that's what is the case. So let's take an example like these are many particles, like many dust particles are flying in the air, and this is the condition. Then it is going to be a system of discrete particles and nothing else. So what is the linear momentum of this discrete particle system? It is E vector total E vector total is equal to summation of phi is equal to 1 to n mi into vi vector. This is the dot product, remember this. That means that we can just add we can say linear momentum of all the particles, and then we will get the total linear momentum. This was the final form. That's how we complete a chapter called linear momentum, and it was very small. So thanks.